Large wave flume. Coastal engineering phenomena cannot be arbitrarily downscaled to be studied by researchers. Sometimes scientists need to know how the water behaves in real conditions, and that is when the following research facilities come into play. Here is a wave generator built at the Leibniz University in Hanover. It's 330 meters long, 5 meters wide, and 7 meters deep. At first glance, it doesn't seem that impressive, but the large wave flume is considered to be one of the largest facilities of its kind. Thanks to this, truly unique experiments can be conducted here. The flume is filled with water until it reaches 5 meters. The maximum height of the wave created is 2.5 meters. The structure consists of a flume, a wave-absorbing surface on one end, and a piston-type wave maker. The latter, by the way, has an incredible design and is equipped with an active wave absorption system, all in order to avoid unwanted waves. A large number of sensors allow scientists to measure a variety of parameters, such as water surface elevation, wave run-up and overtopping, water velocities, water pressures, and more. Earthquake simulator. In places with high seismic activity, people's lives often depend on how solid the building will be. Building a truly reliable structure requires numerous measurements, tests, and trials. The latter are carried out using installations like the one you see on the screen. They usually belong to specialized institutes. This machine, for example, is located at an earthquake research center in Japan, and this one was built at the Beijing Earthquake Research Institute. The machine is basically a huge concrete slab that's pushed from side to side by numerous pistons. The realistic simulation of an earthquake is created by a three-dimensional motion. The platform can swing vertically, transversely, and longitudinally. The power of the equipment varies, especially strong units can simulate earthquakes of magnitude 9 or 10. Storm simulator. At the beginning of this video, we said that water research may not always be conducted in small labs. If you've been wondering how these downscaled experiments look, we will now give you an answer. The fact is that studying natural storms and their consequences in real life is a hard and even dangerous task for scientists. Besides, just imagine how much money it would take to put up a building and then destroy it with waves. To conduct proper experiments without spending millions of dollars, scientists use these amazing storm simulators. This laboratory facility can be found at the Rosenstiel School of Marine and Atmospheric Science. With the help of 143,000 liters of water and some wind, researchers can simulate a small piece of ocean and coastal zone. On the artificial shore, as you can see, there is a tiny building with a huge number of sensors. They measure the degree of deformation, the pressure, the speed of the water, and much more. The scientists use this information to understand how real storms work, and that's how they get an idea of their possible damage. This research will help engineers build more storm-resistant buildings, protecting people inside. By the way, this facility is the only one in the world that's powerful and large enough to simulate a Category 5 storm. Aerodynamic research. There is a technological device that allows scientists to understand how strong winds affect people and different objects. The structure consists of two basic elements: a pipe that accommodates the object, and a wind turbine that consists of one or more fans. The device works similarly for different types of experiments, although its appearance may change. For example, the pipes can be narrow and small. They can be used to conduct experiments on small objects and even people. A more interesting option is using an entire hangar as the pipe. The area inside is large enough to fit a house or even several buildings. The durability and reliability of residential buildings is tested here. As you can guess, to create such an astonishing wind force, you need a powerful plant with lots of fans. NASA Firefly. In the mid-90s, physicists first managed to register the so-called gamma-ray bursts in Earth's atmosphere. TGFs are an electromagnetic emission that charges some particles with an enormous amount of energy, thousands of times higher than the energy of visible light. They only appear due to rare physical processes, and although more than 20 years have passed since the discovery of terrestrial gamma-ray flashes, so far scientists know almost nothing about them. What causes them? Are they dangerous for our satellites? How exactly do these flashes affect other particles? There are far more questions than answers. All that's known is that terrestrial gamma-ray flashes are in one way or another connected to lightning. Maybe they even cause lightning, but that connection hasn't been proved. To learn more about gamma-ray flashes and also about lightning in our atmosphere, NASA developed the Firefly project. In 2013, the tiny satellite Firefly was launched. Tornado Simulator. Every year in the United States alone, tornadoes claim over 80 lives and cause $1 billion in losses. The only way to improve the situation is to study the tornadoes and the way wind forces affect structures. The most interesting tornado simulator is located at the Iowa State University College of Engineering. It consists of two elements. The first is a wind turbine that twists the air, recreating different types of tiny tornadoes. The second is a platform with tiny buildings and a variety of sensors. As in the case of the storm simulator, the information obtained is used to understand how things work in real life. But what's all this for? Right now, there's almost no data on what exactly happens to buildings in the epicenter of a tornado. If scientists can figure out how the wind affects the buildings and where the destruction begins, they can design them in a new way and make them more solid. Flow wave. Here is a high-tech piece of equipment designed to simulate various water phenomena for further study. In this pool, scientists can recreate, for example, huge waves or fast sea currents. Except, of course, no one is trying to create 30-meter waves here. Flow wave works at scales that range from 1 to 10 to 1 to 40. The construction itself is a 25-meter diameter pool. 168 special wave absorbers are placed around the pool. The pool is round, so the water can move in absolutely any direction. By the way, it's driven by 28 pumps. Flow wave is located at the University of Edinburgh. Wave Lab. The last amazing test device we'll be showing you today is located at the University of Oregon. This lab provides many opportunities for scientists and researchers for the study of coastal and nearshore phenomena, for example, how waves interact with buildings. The facility also helps assess tsunami risks, learn more about hydrodynamic processes, and unlock the potential of aquatic renewable energy at a whole new level. As in all other cases, the goal is the same: to increase the resistance of coastal areas against potential threats. In a few decades from now, for example, coastal infrastructure will be designed so that it cannot be damaged by even the most terrible waves.